All right, so now we're going to look at another side of L'Hopital's rule. All right, still going to be the same thing. It's still going to help us find limits without doing a bunch of algebra and simplifying. All right, the only difference here from the previous video is now these limits, the things we're getting for f and g, are infinite instead of 0. So pretty much the exact opposite. Instead of all the top and bottom being 0, the top and bottom are infinite. But L'Hopital's rule says the exact same thing. I just take the derivative of the top, derivative of the bottom, replace them, and hopefully then I can plug in infinity. All right, so let's do some examples. All right, so evaluate the following limit. 3x plus 5 divided by 2x plus 1 as x goes to infinity. If I try to plug in infinity, well, you can't really do that, but I imagine plugging in really big numbers. 3 times infinity is still going to be infinity. 2 times infinity, same thing. All right, both of these are just lines going up. If I plug in an infinite thing, I'm going to get out an infinite thing. All right, so I have infinity divided by infinity says I use L'Hopital's rule. Take the derivative of the top, which is just 3. Take the derivative of the bottom, which is just 2. And L'Hopital's rule says this limit is now 3 over 2. And there's no x there, so there's no x to plug in, so it doesn't matter what x I'm plugging in, whether it's infinite or 0 or whatever. No matter what, I'm just going to get out 3/2. All right, so when you initially learned about horizontal asymptotes, which is what happens when x goes to infinity, you may have just learned it's kind of the coefficients in the front. All right, L'Hopital's rule makes that kind of more plain and obvious, because when you do L'Hopital's rule, everything else pretty much goes away, and you're just stuck with those coefficients for your answer. But the basic calculus idea is you take the derivative of the top, derivative of the bottom, eventually the x's go away, so it doesn't matter what I'm plugging in, I'm just going to get this answer out. All right, let's look at one more. All right, evaluate the following limit, again, where x is going to infinity. All right, the natural log, the graph kind of looks like that, but it's always going slowly up, so if I plug in infinite into a natural log, I'm going to get out infinity. 5 times infinity is still infinity, so we get the same situation. All right, infinity over infinity. So now, we're going to take the derivative of the top and bottom. So the derivative of the top, the derivative of natural log of x. Again, this might be a review because we might not have done this for a while. All right, the derivative of natural log of x is 1 over x. The derivative of the bottom is 5. All right, now we're just going to plug that in. All right, we're going to replace natural log of x with 1 over x. We're going to replace 5x with 5. We can do a little bit of simplifying first. If you have this double division like this, they end up just joining together in the denominator. And now we ask ourselves, what happens to 1 over 5x when x goes to infinity? Here the x doesn't fully go away, but this is enough information to figure out the limit. We can't do L'Hopital's rule again because we have a 1 on the top and an infinity on the bottom. This is a number, just some constant number 1. 5 times infinity is going to be infinity. If you take some number and divide it by a really, really big number, you basically just get out really small numbers. So our limit is going to be 0 in this case. All right, so it seems weird that you can have an infinity divided by infinity, and they kind of cancel each other out so much that the final answer is 0. All right, but L'Hopital's rule. One thing to make sure, it's going to be kind of obvious when we're doing it in class that you're going to be doing L'Hopital's rule a lot. But one thing you technically do have to do first is you have to check that you either have infinity over infinity, or in our previous video we saw you could have 0 over 0. Check that happens first. If it does, then you can use L'Hopital's rule, take the derivative of the top and bottom, and then retry your limit. We also saw you might have to do it multiple times until it finally works. But L'Hopital's rule is nice because it kind of saves you from having to do a lot of algebraic manipulation. Instead, you can just rely on derivatives to get your limits. And here's one problem to kind of test your understanding before class. This limit as x goes to infinity. You can kind of guess it's a video about L'Hopital's rule, so you're going to have to do it. But try it, see what you get, and we could talk about it in class if you have any questions.